Good morning. This is a class on engineering mechanics. In the last class, one problem was shown you where there was rectangular load. There was one beam horizontally kept. Two simple supports were there at the both ends, and few bricks were taken to make the rectangular load. Okay, and ultimately you have got the solution there that both the reaction at point A and reaction at point B, both are same. Okay, you just try to recall or you just watch the previous video. So there you will get that analysis, and that was the simplest, I think, for the case of distributed loads. Now here in this class, we are making the problem somewhat complicated. So before starting the new problem in this class, I want to mention one more thing that you have seen that there were, in a row, there were 10 bricks. Each brick is having the weight of, having the mass of 5 kg. And in a row there was 10 bricks and 6 rows were there. Okay, so what is the total mass? One thing you can see here that the load distribution is same for the entire span of the beam. And the total number of bricks, it is 10 in a row multiplied by 6. 6 rows were there, so 60 rows, 60 bricks. So total mass is 5 into 60, that is 300 kg. So what is the weight? 300 kg multiplied by g, where g is 9.8 meter per second square. So total weight was 300 into g, Newton. So what is the, and length of the beam was taken to be L. No specific value was given in that problem. It was mentioned that the length of the beam was taken to be L. So what is the load per unit length of the beam? So it is very easy to calculate. Total weight is 300 g and total length is L, so 300 g by L. 300 g by L. Unit will be what? Newton per meter. Unit of L is meter, unit of 300 g is Newton, so unit of load or force per unit length is 300 g by L. This is called intensity of load. This is called what? Intensity of load. So this is very easy to calculate because along the length the load distribution was same. Okay, there is no change. Now if I do one thing for the same problem, that 10 bricks in a row, 6 rows along the height, 6 rows, so shape becomes like a rectangle. Now if you take a cutter, suppose just imagine, you take a cutter and cut the triangular road diagonally, okay, like this. Suppose if you take this mirror as the total load, means here 60 bricks are there, total 60 bricks, first row, second row, third row, fourth row, like this. Okay, so 60 bricks are there, and you now take a cutter and cut the total rectangular load diagonally like this, and remove the upper portion. Remove the upper portion. So remaining part is the lower triangle. Remaining part is this lower triangle, this one, this lower part. This is now kept on the beam, and there are two simple supports. So you can see that here the load is more. Okay, at this end is B, and at this end A, there is load is less, minimum load is there. Now load distribution becomes what? Triangular, because shape of this load is like a triangle. So load distribution is not triangle. This upper half is not there. Okay, you have cut this rectangular load diagonally and you have removed the upper portion. The upper triangle you have removed. So remaining part is the lower triangle, and you can see that this is a right angle triangle because this angle is 90 degree. This is a right angle triangle. Okay. Now, what is the total weight here for the same problem? Here, 10 bricks in a row, 6 rows were there. So total weight was 300 G. Diagonal bisects a rectangle into two equal halves. One half is removed. So remaining half should have the weight of 300 G divided by 2, that is 150 G. That is the total weight of the lower triangle. 300 G divided by 2, that is 150 G. So here again, the total downward force is equal to total upward force. Two forces are there, RA, reaction RA and reaction RB at the two ends. Then RA plus RB is equal to 150 G. Okay, 150 G. You can again calculate the weight like this way also. What is this length? It is L. What was the intensity of the load? It was 300 G by L. Then what is the area of this triangle? It is half into this length of the base multiplied by this height. Okay, if you do this, again you will get the same result, that is 150 G. This height is what? This height represents the intensity of the load. This height represents intensity of the load, which is equal to 300 G by L. Okay, so total weight, you will calculate this way. This length half into this length, because area of a triangle is equal to half into base into height. Use that formula here. Half into base into height. Height is the intensity of the load. This end represents intensity of the load. Okay, so half into L into this 300 G by L. So what is the result? Upper L and lower L cancels each other, and half into 300 G, that is 150 G. That way also you can calculate the total load. So one equation is in your hand now, that is RA plus RB is equal to 150 G. Again, one more equation is required to solve the given problem, and that thing you will get by using the principle that algebraic summation of the moments should be 0 since this system is not rotating. So algebraic summation of moments must be 0. So again, for sake of simplicity, we are choosing the point of the moment at the location A. Okay. Say then what will be the algebraic summation of the moment? RA into 0 is the first. Between the reaction RA and the point A, there is no distance. Distance is 0. So RA into 0. Second is weight of the triangular load, which is acting in the downward direction. Okay, which is acting in the downward direction. So total weight is 150 G, and the weight is known, but distance should be known. For the rectangular case, this was the point of center of gravity. the point of intersection of the two diagonals. That was the point of intersection. That was the point of intersection of the two diagonals, and that was the CG. And this CG is at the distance of L by 2. Okay, this distance, L by 2. So that distance was taken for the calculation. But this load is now triangular. Here L by 2 is not correct. So you just take this right angle triangle, the lower one, right angle triangle, and suppose this is now base and this is the height. So from this end, what is the distance of the center of gravity? Or if you say centroid, if you consider this just a triangle, two-dimensional figure, then it will be called as centroid. So what is the distance of the centroid from this end? It is at a 1/3 height from the base. You take this to be the height. Okay, here you take this to be the height, this to be the base. So from here 1/3. Height is what? Height is this much is L. So from this end, distance is 1/3 of L, that is L by 3. So somewhere here, say somewhere here is that point. Along this length, okay? Somewhere here. But point A was where? Point A was here. So we need to know the distance from this point A up to this centroid. So what will be the distance? It will be L minus L by 3, that is 2/3 of L. From this point up to this point is equal to L minus L by 3, that is 2/3 of L. Right? So moment will be that 150 G into 2L by 3 with a negative sign because this is clockwise moment. And I am using the principle, I am using the convention, anti-clockwise moment I am taking to be positive and clockwise moment I am taking to be negative. Right? So this moment is what? Clockwise. So with a negative sign I have to write this. And then reaction RB and distance is same, it is L. From end A to end B, distance is L. So RB into L with a positive sign is the anti-clockwise moment. So algebraic summation of the moments is RA into 0 minus 150G into 2L by 3 plus RB into L. This is the algebraic summation, and this summation must be 0, must be equal to 0. So you put 0 in the right hand side. First term vanishes automatically, RA into 0 was there. In the second and third term, L is present. In the right hand side, 0 is there, so divide both sides by L. Okay? Then result is what? 150G into 2 by 3 means 100G. 150G into 2 by 3 is 100G. So 100G minus 100G plus RB is equal to 0. Minus 100G plus RB is equal to 0. Therefore, RB is equal to 100G. 100G. RB is equal to 100G. Then what is RA? You know RA plus RB is equal to 150G. So RA is equal to 150G minus RB, which is equal to 150G minus 100G, which is equal to 50G. So RB is equal to 100G and RA is equal to 50G. Okay, this is the answer. Here this problem is not symmetric with respect to any vertical line. So RA and RB must be different, and we have seen for this case that RA is 50G and RB is 100G, which are different values. RB is twice the value of RA. Okay, so this was a case of right angle triangle. Shape of the triangle may be anything. Any arbitrary triangular load may be there, and you can solve. the given problem following the same procedure. No separate procedure is required. For suppose a triangle is taken, I am using this mirror here, nothing else is available. Okay. So suppose this is one of the vertex of the triangle, this point, my tip of the finger, this point, okay? And say this is one line, this is the base, the lower one is the base, this is one point, this line, and this line, like this, okay? If this is a triangle, how will you solve this? Here base and height, base is there, where is the height? How do you calculate that centroid, the location of the centroid? Simply, since this is not a right angle triangle, so from the vertex you draw a perpendicular on the base. From the vertex you draw a perpendicular on the base. So the given triangle becomes summation of two right angle triangles. If you draw a perpendicular from the top vertex on the base, then the given triangular node or the given triangle becomes the summation of two right angle triangles. And using two right angle triangles you can solve the given problem easily. It's really very easy. First you try at your home. Then you watch my next video. I'll show you how you will solve a problem like that one. Okay? So this was the end of the problem. Again I want to mention the same thing. If you have any queries, you can write in the comment box. Okay? And one more thing I want to add to this, that only few videos will be uploaded in my Facebook page. And all the videos will be available in YouTube channel. Name of the channel is Triple HD Sciences. If you want to get the notification for all the videos which will be uploaded in near future, then if you wish you can subscribe my channel. Name of the channel is Triple SD Sciences, and just press the bell icon. If you press the bell icon, you will get the notifications for the newer videos. Okay. Thank you. Thank you for attending this class. Okay.